soh-cah. I'm Masters Learning Center at ivmasters.com. Today we're going to look at Test 1, Section 3, number 19, which reads, in a right triangle, one angle measures x degrees, where sine of x equals 4/5. What is the cosine of 90 minus x degrees? Okay, so by the way, whenever it's asking you the sine or cosine of a triangle, 3, 4, 5 is the Pythagorean triple that's most commonly seen on SAT. So if you have no time left and you've got to guess the sine of an angle, guess 4/5 or 3/5. If it's a cosine of an angle, you want to guess 3/5 or 4/5, because those could be opposite or adjacent over hypotenuse, in which case they're going to be 3 or 4/5 if it is in fact a 3, 4, 5 triangle. And if it asks for tangent, which is much less frequently asked on SAT, then it would be 3/4 or 4/3. Now, that being said, what I'm going to do here is I'm going to give you an example using a 5, 12, 13 triangle, which is a different Pythagorean triple. And then what we're going to do is we're going to make a rule that would require you no work to do this problem in particular. So here we go. Here we have a triangle. Note, figure not drawn to scale. Let's say that side's 5, that side's 12, and this side is 13. In that case, if I were to put an x over here, the sine of x would be 12, 13. And I'm going to put a y up here. Let's see what the cosine of y is. Cosine of y is also 12/13. Okay, notice the relationship there. And now I'm going to do is the sine of y. And the sine of y is 5/13. And now I'm going to do the cosine of x. And the cosine of x is also 5/13. Okay. See the relationship there. So here's your rule, and I'm going to type it in the bottom right of your screen, which is if x plus y equals 90, then sine x equals cosine y, and vice versa. It goes the other way around as well. Okay, so there you have it. Now, if we were to look at this problem in particular, we've got a 3, 4, 5 triangle, and granted, that barely looks like a right triangle, but I got the box where the right angle would be. Let's say this is your x. Opposite is 4, hypotenuse is 5. So there's your triangle. And if you solve for the other side, which is actually unnecessary for this problem, but you get 3. 3 squared 9, 4 squared 16, 9 plus 16 is 25. Square root of 25 is 5. So now what we're looking for is the cosine of 90 minus x. I'm going to put a y up here, and I could make a simple equation. X plus y plus 90 equals 180. If I subtracted 90 from both sides, what you would see is that x plus y equals 90. And now, notice this is asking for the cosine of 90 minus x. Basically what I'm doing here is a proof. So y is going to equal 90 minus x if I subtract the x from both sides there. So when you're finding the cosine of 90 minus x, it's the same as finding the cosine of y. And what's the cosine of y? It's adjacent over hypotenuse. It's also 4/5. So it's almost like the College Board is messing with you with this problem. The answer is actually given in the question. But here's your rule. X plus y is 90. then sine of x equals cosine of y, and vice versa. So of course x plus 90 minus x will give you 90. So there's virtually no work to be done here. Sine of x is 4 over 5. Cosine of 90 minus x must also be 4 over 5. Hope you enjoyed our video today. If you liked it, click like. If there's a question that you'd like to see from any official SAT or ACT or PSAT, leave it in the comments. I'd be happy to shoot a video on it. And if there's anyone you know who has trouble with trigonometry, soh-cah-toa, sine, cosine, tangent stuff, feel free to share this with them and click subscribe so you don't miss anything. Have a great day, everyone.